Okay, today we're looking at algebraic fractions, and thing to remember here is that the same techniques for all fractions. Alright, so there's nothing new, nothing different about these. So if we're looking at, say, adding and subtracting, then the same thing that we've got to do is common denominator. Okay, so common denominator is the same as normal numerical fractions. So, for example, let's have a look at some examples. X on 2 plus x on 5, for example. Then we need a common denominator, which for this one would clearly be 10. Okay, so same rules apply again. So we go times 2 by 5, so again top and bottom by 5. 5 we've got to times that by 2, top and bottom by 2. So you've got 5x plus 7x, 2x I should say, not 7x. So 2x. So of course 7x over 10 would be our final answer for that. Alright, so common denominator, so say we have something like this, x over 2 plus 3 over x, same thing, common denominator. Now if you're looking for a common denominator and you're not actually sure what's going to be the common between these things, you can always get a common denominator. It may not be the lowest, but you can always get a common denominator by just multiplying those things together. So looking at 2x as being our common denominator. So the one on the left, you have to multiply top and bottom by x, and the one on the right, top and bottom by 2. So we have x squared over 2x plus 6 over 2x, and so that would then be x squared plus 6 over 2x. Okay, so there's a couple of addition ones, and subtraction, same thing. We need a common denominator. Alright, and as I mentioned previously, the easiest way to get a common denominator is if you multiply those two things together. So in this case, our common denominator would be x times x take 1. So end up with that there like so. The one on the left, you have to multiply top and bottom by x take 1. And the one on the right, we have to multiply top and bottom by x. So what do we end up with? We end up with 3 bracket x take 1 minus 2x. Expanding the left-hand one, so expanding this here, we end up with 3x take 1 over x bracket x take 1 minus 2x over x bracket x take 1. Okay, so final then, over 1 denominator, x bracket x take 1. So then we have combining our like terms, got 3x, 2x. Now don't forget we are subtracting that. So 3x take 2x would be x. X, and then minus 1. Except for I have expanded that bracket incorrectly. That shouldn't be minus 1, should it? And those of you who are on the ball, that bracket should have been expanded as 3x minus 3. So x take 3 over x bracket x take 1. Okay, so let's do one that's just a little bit more involved. So here we've got 2a over x plus 3, and from that we're taking 2 over x take 3. Okay, so as I've mentioned, the easiest thing to do is multiply your two brackets together, and so we have that there. So here we're top and bottom by x take 3, and here we're top and bottom by x plus 3. Okay, so 2a outside of x take 3 and 2 outside of x plus 3. Alright, so there's our common denominators. Okay, so expanding these ones here, you get 2a times x, so 2ax, and 2a times negative 3 minus 6a. Then expanding those ones, you get 2x plus 6. So then finally, we have a common denominator, x plus 3, x minus 3. And on the top, well, there's not a lot we're going to be able to do with that. So 2ax, because there are no like terms, minus 6a, minus 2x, minus 6. And that's what we end up with. You could expand out that bottom bracket, two brackets if you want to, and just normally you wouldn't actually do that until the end, just in case there's some sort of common factors, which in this case there is not, but just in case there was some common factors, and then after you've done those, they might, cancel out. Alright, so there we go for addition, subtraction. Of course, we can also multiply and divide, and again, multiplying and dividing is the same. Alright, so here we cancel common factors. Right, so if we can, and so for and also for division, we need to first flip and multiply. Okay, for those, so let's have a look at a couple of examples. So 3x squared on 4 times 20 over 9x. Alright, so let's have a look at some cancelling. Okay, 4 goes into itself once into 25 times. 3 goes into itself once and into 9 3 times. X goes into itself once there, and x times x squared gives us, x times x gives us x squared, so that cancels. Alright, so what do we end up with? On the top line we got 5x, and on the bottom line we got 3. Alright, so reasonably simple. Get rid of that. So then if we've got x squared plus 4 over 6y squared divided by 5x squared plus 20 over 2y, for example. Before we start, we've got to do something about this. Okay, so to do something about this, we turn it into a times, but when we turn it into a times, we've got to flip this. So that then becomes 2y over 5x squared minus plus 20. And the first fraction stays as it is. Okay, then we look at if some factorising, or if we can. Anything can be factorised. First fraction, nothing can be. Second fraction, on the bottom 5 can come out as a common factor. And then left us with x squared plus 4. So now we look at some cancelling. X squared plus 4 goes into itself once. 2 goes into there 3 times, and 2 goes into 2 once. And y goes into itself once, and y squared y times. So on the top we'll have 1. And on the bottom we'll have 15y. So there's our answer. Alright, CAS calculator can also be used for those things, so the combine function, simplify function will work for those. There should be a calculator sheet available for that. Alright, so that's problem set number 5, that's exercise 4F.